Welcome to HB Tuners for Gen 2 Coyote Training Part 36. This training module, we're going to be taking a look at how we can do a quick spark tuning demonstration on a Gen 2 vehicle. So we're going to go from having stock spark timing tables, going and making adjustments, and then being able to read the data logs and making some more adjustments on a chassis dyno so you can see the results before and after, starting off with stock spark timing tables, then how we dial them in for performance gains and also making sure that the engine's going to be safe. So let's jump in here so we can check out working within dialing in our spark timing.
Okay, so let's get started. We're going to be taking a look at how to dial our spark timing in for a Gen 2 Ford Coyote application. Now, we've had two other training tutorials taking a look at spark timing, the basics, and then how all the spark timing routine fits together in the last tutorial. This tutorial we're going to be focusing on here, doing a demonstration on a chassis dyno so we can see the before and after of adjusting our spark timing. The majority of the gains we'll find on a Coyote, so after you've dialed in your fuel and airflow model, are usually not found in the variable cam mapping. It's usually found in adjusting the spark timing. Now we want to have safe, conservative spark timing values to dial our fuel airflow model in. The spark timing will be one of the last things that we adjust in our calibration process, which is why I have it here towards the end of the training course. This is one of the last things I want to focus my attention on. The stock values for a bolt-on Coyote are completely safe to run. I'm going to try to optimize this and pick up additional power. So we'll see what's left on the table to gain by adjusting our spark timing. So what we're going to do is baseline this with the stock spark timing routine, then we'll go in and make some adjustments, and then we'll see if we can gain power. We're going to be looking at our VCM scanner at some data logs, looking at the dyno example, the actual dyno screen. I have that recording here as well, so we'll be able to go back and forth, just seeing the before and after by making our spark timing adjustments. Now, going on a chassis dyno is the most ideal thing to adjust your spark timing, but you don't need a chassis dyno in order to dial your spark timing in. All you need to do is pay attention to what your logging is showing and what your knock control is showing you. So if you're able to run a bit more advanced and you're not getting any knock activities, chances are you're going to be gaining power from those spark timing changes that you've made, advancing the timing. But we don't want to go in and have knock retard happen, which means that there's knock activity, and we're essentially putting spark timing in the borderline table, or however we're adding it. There's a couple different options we'll talk about here in the tutorial. We're going to be adding more advance in, and the engine control module is going to be fighting us and pulling that timing back out. We don't want that happening. We want to be able to add the timing in and have a very small margin that it's adding additional timing above and beyond what the timing that we're commanding from all the spark timing mapping is going to be. So let's jump in here. Let's take a look at the stock tables here real quick. This is going to be this particular calibration file we're working with is everything we've carried through all the other tutorials in the training course. That means that we've dialed our MAF in, we've dialed speed density in, we've dialed our torque tables in. Everything is 100% on this vehicle, so spark timing is this last bit that I want to go in and dial in. So that's what I'm using right now. So let's look at the stock spark timing routine. We're going to go here into our engine tab, and then we're going to go from general over into spark. Now under advanced tab under spark here, we're going to find, if we scoot down here, we're going to find our borderline table. And we know we have our different map points that can be called on. There's 26 total map points. We don't use optimal power, so that's not going to be referenced. But this is going to be following along to our VCT scheduling. Under full throttle, really where we're focusing on dialing our spark timing in for this tutorial, we're going to be finding that the map points 18 to approximately 24, 25 are going to be what's called on. There are other map points, but we have our charge motion valve assembly is going to be open under full throttle conditions as we're entering into the higher RPM, higher throttle, higher load type of environment, and we'll find that we're really calling on the last bit of our map points. So from 18 to approximately 25 is really what we're going to be working with. Now we can log the VCT scheduling to confirm which specific map points are called on, so we know which specific borderline tables are sourced. The spark timing is going to start here in borderline, and then it's going to be running the lowest value in terms of the spark timing compared against the borderline to the maximum brake torque, to the pre-ignition, or to the cylinder pressure limit. So we'll find whatever the spark timing is going to be the lowest between these tables is going to be what it runs. So if, for whatever reason, we have our borderline table value here, and then we have our knock control adding advance to the borderline table, and it just so happens to reach the threshold against the same map point table in, let's say, maximum brake torque, let's say we're referencing map point 20, if it starts to reach the values here in maximum brake torque, it'll show that as the limit in our spark source, it'll actually show that as maximum brake torque and not borderline. We like to see that borderline is what we reference the entire time we're at high load, high throttle situations, but it can be limited in spark timing to the maximum brake torque, the pre-ignition limit here, or the cylinder pressure limit. Now, typically, if it's going to be hitting any of the caps or the limits, it is going to be the cylinder pressure limit is going to be what it hits first. That is typically the lowest of the values between these three tables. So we start at borderline, we advance the timing with our knock control, and then we cap it between one of these three tables here to prevent an unsafe condition. Now, when we actually go in and make our changes, we're going to be raising our thresholds up here and at least the cylinder pressure limit to be able to make sure that we can run timing past this point. We have basic bolt-ons. So we're naturally aspirated basic bolt-ons in our S550 example here. So we have basic intake, header, high flow cats, and exhaust. On the 2017 Mustang GT automatic that I'm working with here on the chassis dyno, we're going to find that we do need to raise the cylinder pressure limit up because we can run a bit more timing than stock, the stock borderline, plus the advanced values from the knock control than what we have.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.